Hello everyone. Today we are going to solve few more problems on the losses of pre-stress. So today's first problem: a concrete beam 10 meter span, 100 mm wide and 300 mm deep, pre-stressed by 3 cables. The area of each cable is 200 mm square. The initial stress in the cable is 1200 Newton per mm square. Cable 1 is parabolic with an eccentricity of 60 mm above the centroid at supports and 50 mm below the centroid of the midspan. Cable 2 also parabolic with 0 eccentricity at supports and 50 mm below the centroid at the center of the span. Cable 3 is straight with uniform eccentricity of 50 mm below the centroid. If the cables are tensioned from one end, estimate the percentage loss of pre-stress in each cable due to friction. Assume mu equals 0.35 and K as 0.0015 per meter. So here we have a beam of size 100 by 300 and a span of 10 meter. It is pre-stressing by 3 cables, each of area 200 mm square with the initial stress 1200 Newton per mm square. The cable profile is given. So we know one cable 1 is having 50 mm eccentricity at support above the centroid and 50 mm eccentricity at midspan below the centroid. Second one is 0 eccentricity at support and 50 mm below the centroid at midspan, and third one is straight. Here you need to see the question. If the cables are tensioned from one end, that is the total span is 10 meter, if you are pulling from 0 end, the cable is first you have fixed the cable at 10 meter and from 0 meter end you are pulling the cable. That is the condition. Here you need to find out only the loss due to friction. So here data given: mu is coefficient of friction and K is wave effect. Details. So here we know the formula for loss of pre-stress is due to friction, P naught into mu alpha plus Kx. So mu is coefficient of friction, K is wave effect or wobble effect we can say, and X is at which distance you are calculating the loss. But alpha, it is the cumulative angle of the tendon with two ends. So we need to find out what is the slope of the cable at both ends, end A and end B. At both sides we need to find out the slope. Since it is parabolic tendon, we need to take the equation of parabola, that is y equals 4 E star by L square into Lx minus x square. So E star is total dip of the cable, so that is from at support above 50 mm and at midspan below 50 mm. So total it is 100 mm. So E star will be 100 mm. So to calculate the slope, we have first derivative dy by dx is equal to tan theta, we know. So same equation we are going to equate. So differentiate this with respect to x. Dy by dx equals 4 E star by L square is constant, keep it as it is. So L into x, the differentiation of x is 1, x square is 2x, so L minus 2x. Here tan theta equals 4 E star by L square into L minus 2x. So since we are calculating at support section, x will be 0. So we will get theta A. The eccentricity at both ends is same, so the slope of the tendon at both ends will be same. So theta A equals theta B. So alpha will be theta A plus theta B, that is cumulative. This condition is when you are applying the or tensioning the tendon from one end. Another case we will discuss later. So loss of pre-stress, substitute the values. Mu is given, P naught it is initial pre-stress, alpha you have calculated, K is given, and X. So one end is fixed and from another end you are pulling the cable, means the loss will be throughout the span of the beam. So at another end, the fixed end, what is the loss you need to find out. So X will be 10. So this is loss of pre-stress 51.6 Newton per mm square. So for that you need to calculate the percentage of loss. So this loss what you have calculated, it is only for cable 1. Same way we need to find out for cable number 2. Here there is no eccentricity at support and eccentricity of 50 mm at midspan. So total depth of the cable is 50 mm. Again X will be 0. Same equation you need to consider. The only change is eccentricity or E star value. You will get 0.02 as theta value, alpha will be 0.04. Substitute and you will get the loss. And for third cable, since it is a straight cable, there is no slope at all, alpha will be 0. So directly we can substitute the remaining values and we can calculate the loss. This is loss of pre-stress due to friction. Next, let us move on to second problem. A post-tensioned concrete beam 200 mm wide and 450 mm deep is pre-stressed by a circular cable. Total area of cross section for cable is 800 mm square with eccentricity at ends, with zero eccentricity at ends. There's a print mistake. With zero eccentricity at ends and 150 mm at the center. The initial stress is 840 Newton per mm square in the unjacked end immediately after the anchoring. Determine the stress in the wires at the jacking end and percentage loss of pre-stress due to friction. The span of the beam is 10 meter. Take mu is 0.6 and K as 0.003 per meter. Yes. See, in this problem, 3 new things you are seeing. One is cable profile is circular, and here he has mentioned an unjacked end, and you need to find out at the jacking end. These are the 3 parameters you need to remember. So here also you need to find out loss of pre-stress due to friction only. So first, to calculate friction, we need the slope of the cable, and he is given the pre-stress initial stress at unjacked end. So 10 meter span is there. One end it is fixed and another end it is applying the tension force. So the end which you are applying the tension force, it is called jacking end, and the opposite end where we have fixed the tendon at the beginning itself, that is unjacking end. So in that fixed end it is given 840 Newton per mm square immediately after the anchoring, that is after applying the tension force and anchoring at the jacking end. The stress remaining at the unjacking end is 840 Newton per mm square. So if you want to maintain 840 Newton per mm square at the unjacking end, what is the pre-stress applied at the jacking end you need to find out, then the difference will be your loss. So first we need to find out the slope. So for that we need the radius of the cable, R value we need to find out. So from triangle OAB by Pythagoras theorem we can calculate this distance, and R minus 0.15 we can calculate, or the hypotenuse we can calculate R square R is 83.4. So sin theta A equals AB by OA so we will get 0.06. Here remember, for radius the tangent always will be perpendicular. So we have got alpha value. Here we have one more equation in the same friction, that is Px equals P naught into 1 minus mu alpha minus Kx. Again substitute the same values, or substitute all the values. Px, it is given unjacking and stress. So Px is stress at any other place apart from the end where you are applying the tensile force, and P naught is the initial pre-stress which you are applying at the angle jacking end, or the end where you are applying the tensile force. So P naught we need to find out. Px is given 840, at 10 meter distance it is given. So 1 minus mu is 0.6, alpha 0.12 we have calculated, K is 0.003 given, and 10 meter is the span. So P naught equals this much. The difference of P naught minus Px will be loss of friction. So for that we have calculated the percentage. Next problem. A concrete beam of span 10 meter is post tensioned by a cable with initial stress of 1200 Newton per mm square from one end. The cable is concentric at supports and has an eccentricity of 100 mm at the center of the span. Coefficient of friction due to curvature effect is 0.5, and friction coefficient for Hubel effect is 0.003 per meter. Compute the loss of pre-stress in the tendon, assuming the cable to have circular profile and parabolic profile. See, in this problem, the previous problems what you have solved, 6th and 7th, both problems you need to solve in same problem. That is the thing, that's it. So here see, friction due to curvature effect, it is the value of mu, and friction due to Hubel effect, or it may be given as wave effect, it is the value of K. You should remember those two things. So first find out the radius, then slope. You will get the alpha value, substitute in the equation. Initial pre-stress itself it is given, so directly consider as P naught. You will get the loss. And parabolic profile, again in case parabolic equation you need to consider. First case is circular and next case is parabolic. So same parabolic equation you need to consider and find out the slope, calculate and substitute the values, you will get the loss. Next problem. A simply supported post tension concrete beam of span 15 meter has a rectangular cross section 300 mm by 800 mm. The pre-stress at the end is 1300 kN with zero eccentricity at supports and an eccentricity of 250 mm at the center. The cable profile being parabolic, assuming K equals 0.15 per 100 meter, that is 0.0015 per meter, and mu equals 0.35. Determine the loss of pre-stress due to friction at the center of the beam. See here, remember the term here you need to find out at the center of the beam. That is very important. So E star, it is depth of the cable, X where you need to find out the loss of pre-stress, that is the total span is 15 meter and at center of the beam means 15 by 2, it is 7.5 meter. Mu is given, K is given. Take the equation for parabola, differentiate it, you will get tan theta. First you need to find out the slope at supports, that is theta A, x equals 0, substitute the values, and at theta C means theta at the midspan. It is at midspan the tangent will be exactly horizontal. It is along the x-axis. So theta will be 0 for the center of the span. You can observe in the figure. So theta c is 0. In previous problems you have calculated from one end to other end, but here you are calculating from end to midspan. So end slope we have, mid slope at midspan it is 0. So alpha will be is theta a plus theta c. Theta a is 0.066 and theta c is 0. So alpha value we got. Initial stress, pre-stressing force is given, it is 1300 kilonewton, and area of the section is given. You will get P by a, load by area. We will get stress, initial stress P naught we are going to get. So loss of pre-stress mu alpha plus kx. Simplify, you will get the answer. Next problem. A post tensioned cable of a beam 10 meter long is initially tensioned to a stress of 1000 Newton per mm square at one end. If the tendons are curved so that the slope of the ends is 1 in 24 with cross section area of 600 mm square, calculate the loss of stress due to friction with the following data. So coefficient of friction between the duct and the cable, it is 0.3, it is mu value. Friction coefficient for wave effect K, it is 0.0015 point per meter. So slope is directly given 1 in 24. So theta here you can directly consider 1 in 24. Since it is parabolic, it is not mentioned anything. So directly you can consider the slope itself, theta A and theta B. Mu is given, K is given, X is 10 meter span, initial stress is given. So calculate the loss and percentage of loss. That is the problem. Here the change is theta is directly given. That's it. Thank you.